Hi everyone, welcome to the next video in Unit 3. We're still graphing trig functions, and in this video I want to go over some more about phase shifts and also writing equations from graphs. So take a second and see if you understand the cartoons that I put on this screen. So I found this graphic that I thought would be really handy for you to have, because it shows basically everything that you need to know about graphing trig functions. So you can see here that you have a sine curve. You can see the sine curve right here. You can also see what an amplitude, the amplitude marked. You can see what a period is. Remember that on a trig function it just has to do with, once it completes a pattern, then it just completes that pattern over and over again. It shows the domain. The domain of the function is all real numbers. And the range goes from -1 to 1. That's the basic sine function. And then you can see here, in general, you can see that A is the amplitude, B is going to be the period. This is how you find it. And then we're going to add to this a couple of other observations. So stay tuned. So in transformations of sine and cosine curves, we're going to talk about phase shifts. We've talked about amplitude, we've talked about period. We can do a shift right or left. We could take that function and we could shift it up or down. And so you can see that I have the general equation written right here. You can see that this D is going to be a shift up or down. The A is a amplitude. B is used to find the period of the function. And this C value, just like you would on any function, because it's inside the parentheses, that sign is opposite what you think it will be. So because this is a minus sign, you would move this right. If that were a plus sign right here, you would move it left. Just like for a quadratic or any other polynomial, if it's inside of parentheses or under a square root, then you do opposite of what you kind of think the sign is going to be. Now, sine and cosine are called sinusoidal graphs because all cosine graphs can be modeled with a sine equation because they are, you can see, very close. So I put a graph on here of sine. You can see that it starts at 0. This is really hard to see. I don't actually have pi here, but this is pi over 2, this is pi, 3 pi over 2, and 2 pi. I put the decimals in there. This is Desmos. And then you have this function right here. If you see this blue function starts at 1, but it has the same amplitude and period as sine. This is cosine. So the blue is cosine and the red is sine. And if there was some way that I could pick up the blue, you could kind of see that if I just moved it over, it would sit right on top of sine. So this is sinusoidal. So what that means for you is that the graph, or y equals sine x, and the equation y equals cosine x moved to the right, pi over 2, will get you the same graph. Okay? The other thing I wanted to show you on here, and I'm going to talk about this in class again, is that b needs to be factored out. So for instance, if I had y equals 2 sine 2x plus pi, right? So if this were in parentheses. Now you can tell very quickly what b is going to be, right? That b for the period, 2 pi over b, will be 2. But this is the phase shift. And the phase shift is left because that's a plus sign, but it's not pi. You have to factor out the 2 before you do that. So if I took this function and I would say 2 sine 2 and then x plus pi over 2. Now multiply that out if you don't believe me, right? So 2x plus will get you back to pi. This is the phase shift. So the phase shift would be left pi over 2. Okay, so make note of that in your notes, please. So once again, I've given you a couple other graphs from Desmos that will show you how you might move one to the other. So you can kind of see here that the red is sine. So you see sine here. And blue. What is blue? Well, Blue looks like, see this starts at -1 instead of 1, so it looks like a negative cosine, right? So this blue is negative cosine. If I could write it, negative cosine x. So if I wanted to put those next to each other, I still could move it, but I would want to move it pi over 2 that direction, and that would be left, right? So this would be y equals negative cosine x plus pi over 2, and that would get it on top of it. Same deal here. So let's look at this graph. If we're looking at this red graph here, you can see that it starts at 0, but it goes down first. So this is going to be negative sine. And then what is the other one? Well, the other one starts at 1 and ends up at 2 pi. That's just cosine x. All right, so I have one and I have the other, so then I have cosine x. How would I lay one on top of the other? Well, if I want to lay the red on top of the blue, you can see very quickly that I'm going to move it to the right. So I would say this would be, if I were writing them so that they would be equal, to the right would look like that. Now, as you're looking at that, you're going, wait, Ms. Bonnefeld, that's not right. That won't set it on top of each other. And you would be correct. So let's look at this again. Right? I have the red, and I want to put the blue. I don't want to move the blue to the right. I want to move the blue to the left. So that would be cosine x plus pi over 2. Okay? And there are numerous ways you can do that. You probably have thought of several others, and that's really good if you can get to that point. Okay, so here is an example. We're going to start writing equations from graphs, all right? And so I've kind of given you a help down here as a little fill-in thing that we can use. We need to know what the amplitude of this function is. So when we go to look, right, we are kind of following. Notice that this starts at here, not 0, so this is probably a cosine function, right? So we need a parent function. Our parent function, I'm just going to call that like that, parent function is going to be cosine x. That's the easiest. Could I make it sine? Absolutely I could make it sine, but then I have to add a phase shift, and those are a little harder. So I'm going to make it easy on myself and use cosine. Well, what's the amplitude? Well, I look to see where halfway. Notice that this is halfway right here, and notice that it is not phase shifted vertically or horizontally if I use cosine. So it's not, so that means halfway through. So I look up 1, 2, 3, the amplitude is 3. The period looks like it's shortened. The period is shortened to pi. Well, I need b to write my equation, so 2 pi over b is going to equal the period. If I multiply times b, right over here, then and divide by pi, b is going to equal 2. All right, so I know that A, amplitude is 3. I know B is 2. It is not phase shifted right or left or up or down, and I'm using cosine. So y equals 3 cosine 2, and I'll just use x. You could use theta there if you wanted. So on this one, we notice it looks extra long. It's centered on the origin. But we can see that the entire period has been depicted here in this picture, and it's going from what looks like negative pi over 2, negative 2 pi to 2 pi. So that makes our period 4 pi. The amplitude, as I look up, is 2, so I know what A is. I don't know what B is, but I can figure it out pretty easy. 2 pi over B is 4 pi. Put the B over here, divide, that's going to be 1/2. Okay, so I have that. Notice that when it was 2, it was skinny, right? It was squeezed this direction, but when this is a fraction, it's going to be expanded. And that's going to always be true. Is it moved up or down? No. Left or right? No. So what's the easiest of the sinusoidal functions? Which one? Sine of cosine would be the easiest. Right? Well, if I start over here, it starts at 0. That's what sine does, except sine usually goes up first. This time it goes down. So you're right, that's going to be the parent function of this is going to be negative sine x. Okay? So could I use positive sine x? What do you think? Well, if you think this is all the graph there is right here, right? If you think this is the whole graph, but realize it's not, it goes this way. So what is this? That is sine. Do I need the negative? I don't. Can I leave it on there? Sure. But you'd have to do a phase shift. This would be a phase shift. So the parent function is actually, I'm going to do the easy route, is going to be sine x because it starts at 0. So y equals 2 sine 1/2 x. So on this particular one, I want you to stop the video and try working it on your own. I want you to try to analyze it on your own and then come back. If you want to, you can fast forward to the end and see if you have the correct equation. And keep in mind, you might have a different equation that's equally correct. So anyway, here we go. So on this one, you can see it has an amplitude. Now, on most of these, it's not going to draw in halfway between, right? But can you see that there's half above and half below? This is telling me that I have a shift down. Well, how far down? Well, it looks like 2. So I'm going to have vertical shift would be down 2. Because there's a shift, it's going up 1, down 1, so the amplitude is still 1. And the period looks like it has shrunk down to pi. Well, we know from before, I mean, we can do it again, but 2 pi over b equals pi, and then you do b here and you divide, so b is 2, right? So a is 1, b is 2, and we have a vertical shift down, so that's going to be, and then we need a parent function. Well, it looks like to me that unless I do a phase shift, which I could, it starts at 1. So the parent function, the easiest parent function, would be cosine. Now, if I pick the parent function to be sine, right, then sine is 0 here. So, and it's upside down, right? So this phase shift. Or I could do all the way to here, right? That should be at 0, but it's not. So this is at what? Well, this is pi over 4. This is pi over 2, so this is 1 pi over 4, 2 pi over 4, this is 3 pi over 4. So I could do a phase shift to the right, and the right 3 pi over 4. Okay, so let's write it both ways. So let's do one with cosine, right? So y is, the amplitude is 1, cosine, and then the period b is 2, so 2x, and then down 2. So that's one way to do it. Another one would be same amplitude, this time it's sine. B is still this. Notice I'm going to put this phase shift to the right in parentheses, right? Because I want to retain this value. So this is going to be x minus 3 pi over 4, and then down 2. So how'd you do? I hope you did well. Okay, so this one I created in Desmos. I would like for you to write the equation for this line and bring it to class. If you can find more than one equation, for instance, make one that's sine and then the other that's cosine. If you can add a phase shift, either right or left, up and down, whatever. But be prepared to do these kinds of problems in class and bring this problem. This will be probably our introductory activity. Okay? And I'll see you in class.